టైమింగ్ కూడా పోతుంటే తీసేస్తున్నాయి.
తీసేసింది స్టార్ట్ అయింది చూద్దాం అదే ఉంటుంది ఒకసారి
చూడు ఎంతవరకు మార్పు ఇక్కడ వరకు క్లారిటీ రాదు ఇంతవరకు ఇటువైపు ఇంతవరకు పెట్టుకుంటా అంతేనా?
అంతే అంతే చాలు
చాలు.
వస్తుందా ఇప్పుడు కనిపిస్తుంది
ఓకేనా? బిగిన్ చేయొచ్చు. Welcome to Laksha YouTube channel. Good morning all students. Today topic name ionic equilibrium. Ionic. Once repeated. Today topic name ionic equilibrium. Briefly discuss in ionic equilibrium. In ionic equilibrium, first to discuss acid base theories. In ionic equilibrium, first to discuss acid base theories. Acid base theories are three types. Acid base theories are three types. First one, Arrhenius theory. Arrhenius theory. Second one, Lowry Brownistedt theory. Third one, Lewis acid base theory. According to Arrhenius theory, what is acid? According to Arrhenius theory, acid is defined. What is acid? According to Arrhenius theory, what is acid? A substance dissolved in water to produce H plus ion. This substance is called Arrhenius acid. Example: HCl, HNO3, H2SO4, etc. What is Arrhenius base? What is Arrhenius base? A substance dissolved in water to produce OH minus ion. The substance is called Arrhenius base. For example, NaOH, KaOH, etc. In objective point of view, important point. According to Arrhenius theory, water is neutral solvent. Neutral solvent. Water is a neutral solvent. What is the merits of Arrhenius theory? According to Arrhenius theory, to explain strength of acid and base. What is the meaning of strength of acid and base? The given acid, strong acids or weak acids, the given bases, strong acids or strong bases, depend upon alpha value. Here alpha, degree of dissociation of electrolytes. What is the meaning of degree of dissociation of electrolytes? For example, a substance 1 mole dissolved in water, how much percentage of ions undergo dissociation? Degree of dissociation, based on degree of dissociation, according to Arrhenius theory, alpha value equal to 1. The acids, the electrolytes, the bases are strong electrolytes. Strong electrolytes. According to Arrhenius theory, alpha value less than 1. The electrolytes are weak electrolytes. Examples: weak acids, weak bases. What is the demerits of Arrhenius theory? Arrhenius theory only applicable aqueous solutions, not applicable non-aqueous solutions. For example, it failed to explain acidic nature of CO2, BF3, AlCl3, etc. And also failed to explain basic nature of ammonia, CaO, calcium oxide, etc. Another failure, it failed to explain catalytic activity of H plus ion. Catalytic activity of H plus ion. Once repeated. What is failure of Arrhenius theory? First failure, it failed to explain acidic nature of CO2, BF3, AlF3, etc. compounds. It failed to explain basic nature of NH3, CaO, etc. It failed to explain catalytic activity of H plus ion. Important note. What is important note? H plus ions, H plus ion, OH minus ion, H plus ion, OH minus ion. In aqueous form, to exist hydrated form. How to exist? To exist hydrated form. Why H plus and OH minus ions to exist hydrated ion form? Simple reason. Very small size ions. So in aqueous form, H plus ion exists. H3O plus hydrated ion form. H plus ion undergo hydrolysis. First exists H3O plus ion. Further hydrated. The formula converts H5O2 plus. Further hydrated. The formula converted H7O2 plus. Further hydrated. The formula converts H73 plus. Further hydrated. The formula converts H9O4 plus once repeated. H plus ions and OH minus ions in aqueous form to exist hydrated ion form because H plus and OH minus ions very small size. H plus ion exist in hydrated form in the following formula: H3O plus, H5O2 plus, H7O3 plus, H9O4 plus. In these ions, due to presence of hydrogen bonds, why H9O4 plus ion exists due to presence of hydrogen bonds. Similarly, OH minus ion undergo hydration to exist. H3O2 minus further hydration to exist. H5O3 minus. This is concept of Arrhenius theory. Next theorem. Next theorem. Lowry-Brownsted acid-base theory. Lowry-Brownsted acid-base theory is also called proton transfer theory. This theory, what is acid? A substance donate proton, other substance, the substance is act as a Lowry-Brownsted acid. What is base? A substance which accept proton, other substance, the substance is act as a Lowry-Brownsted base. According to Lowry-Brownsted theory, acid base reactions are reversible reactions. Acid base reactions are reversible reactions. For example, HCl react with water. In this case, HCl donate proton, water. HCl is act as a Lowry-Brownsted acid. Water accept proton, it act as a Lowry-Brownsted base. This process is discussed in forward direction, similarly in backward direction to form H3O plus and Cl minus ions. In reversible reaction, H3O plus ion donate proton, it act as a acid. To Cl minus ion accept a proton, it act as a base 2. It means all Lowry-Brownsted acid base reactions are reversible reactions. Next up, conjugate to acid base pair. What is conjugate to acid base pair? Which pair difference one proton? That pair is called conjugate to acid base pair. For example, in this reversible reaction, HCl, Cl minus ions are act as a conjugate to acid base pair because HCl is act as acid, Cl minus is act as a base, which differ by only one proton. Water, hydronium ion is also example of conjugate to acid base pair. In objective point of view, important note: number of conjugate to acid base pairs, number of number of conjugate to acid base pairs equal to, once repeated, number of conjugate to acid base pairs formation equal to basicity of acid plus 1. For example, HCl basicity 1, it possible 2 conjugate to acid base pair. H2SO4 basicity 2, it possible 3 conjugate to acid base pair. Once repeated, number of conjugate to acid base pairs formation equal to basicity of acid plus 1. For example, HCl basicity 1, it possible how many conjugate to acid base pair? 2. H2SO4 basicity 2, it possible 3 conjugate to acid base pairs. Another important term, conjugate to base, conjugate to base. The formula of the conjugate to base is equal to substance minus substance, given substance minus H plus ion. Once repeated, the formula of the conjugate to base is equal to substance minus proton. For example,